Okay, I think multiplying and dividing expressions is actually easier than adding and subtracting, because you can multiply unlike terms. So for example, in A it's 5 times 4g. They're not like terms, but it doesn't matter. We can multiply them together. So what we do is we say, what's 5 times 4? 5 times 4 is 20, and then we just put the letter G there because that's the only letter. In the next one, negative 3d times by 6ab times by 7. This is the way I like to go about it, and I think you might find it easier too. So let's look. So let's look at initially just the numbers. So 3, 6, and 7. So 3 times 6 is 18, and 18 times 7 is 126. So we've looked just then at the numbers. Now we're going to look at the letters. We've got a D and an A, B. So we just write D, A, B. And now we look at our signs. We have a negative times by a positive times by a positive. So a negative times by a positive gives us a negative, times by another positive gives us a negative. So that would be our answer, negative 126 DAB. That answer is acceptable, but it is more conventional or more normal that these letters are written in alphabetical order, A, B, D. Not compulsory, it's just the more normal way that you would see it. So that's multiplying. Okay, we don't have to worry about if things are like terms. Let's multiply that. I call them the big numbers, then multiply the letters, then look at the signs involved. Okay, with division. I find it much easier that when dividing expressions, rewrite them as a fraction. So this first example is already as a fraction. Remember that when the same variable or the same letter appears as a factor on both the numerator and the denominator, it may be cancelled. So we have 16f over 4. Again, we don't have to worry that they're not like terms. For division, it doesn't matter. We can cancel this down because 4 goes into itself once and 4 goes into 16 4 times. So the answer to the first one is 4f. Our next one, rewrite this as a fraction. I do think you'll find it much easier. So we write that as 15n divided by 3n. See, it's exactly the same, just written in a way that I think will make it easier for you. Hopefully you can see if there's an n on the top and an n on the bottom, you can cancel those. 3 goes into itself once and 3 goes into 15 5 times. So the answer is 5 over 1, or more normally written just as 5. Okay, now we're going to start having some negatives. So we've got a few examples to go through here. Negative 12xy divided by 27y. Let's rewrite it as a fraction. Once we've rewritten it as a fraction, hopefully you can see y on top, y on bottom. 12 and 27. Something goes into them both. 3 goes into them both. Goes into 12 4 times, and it goes into 27 9 times. So let's write out what we've got on the top. We've got negative 4x, and on the bottom we have 9. We just do a double check to see if anything else cancels. Nothing else cancels, so that's our answer. Okay, 4 more. 6m cubed times by 2m. Hopefully you remember if we put a 1 there, so 2m to the power of 1. Multiplication, so it doesn't matter that they're not like terms. Let's multiply our big numbers. 3 times 2 is 6. Now we've got m to the power of 3 times m to the power of 1. This brings our indices topics into play. When we multiply them, because they're both m's, you add the index numbers. So we get the answer 6m to the power of 4. Our next one. Let's look at our big numbers. 5 threes are 15. So we write 15. It's a multiply. They've both got the same base of p. So we add those indices, so it's 15p to the power of 13. Okay, for C, let's rewrite it as a fraction. Okay, looking at our big numbers, 12 goes into itself once, 12 goes into 36 3 times. Now, both have the same base and it's a divide. What do we do to those indices if it's a divide? Your index law unit said if they both have the same base and it's a divide, you subtract the index numbers. So we write our 3, and then we write our x to the 7, subtract 4, which is 3x cubed. Last one, I'll rewrite it, d. 6y cubed times by 4y to the power of 8 over 12y to the power of 4. I would like you to ignore the bottom temporarily, so hide the bottom and just look at the top. If we just had the top, 6 times 4 is 24. Then we've got y cubed times by y8. Both the same base and it's a times, so we add those indices. So on the top we end up with 24y to the power of 11. Then we've got our bottom, 12y to the 4. Let's look at it. Let's look at the big numbers. 12 goes into itself once and it goes into 24 2 times. So we've got our 2. Now let's look at our y's. They've both got base y and it's a divide. So remember, for our index laws, if they're both the same base and we're dividing them, then you subtract those index numbers. So we end up with 2y to the power of 7. So this is pretty good because it combines our unit of index laws as well. And also remember that when you're multiplying and dividing, it does not matter if they're not like terms.